Okay, let's look at two little applications. What we have first is distance traveled over time for a child going on a horizontal water slide. So if you've ever been on a water slide, you may understand why this graph has the shape it does. When you hit the water slide, you are flying on that water, but then as time goes on, friction between your body and that water slide occurs, and you start to slow down until eventually you do stop and don't cover any more distance. So part A says describe the velocity of the child during the first 2 seconds of her journey. And we can say it begins with the highest velocity. And again, if you've ever been on one of those water slides, you probably understand. You start really fast and then you slow down due to friction. Okay. Part B, due to friction. By drawing suitable tangents to the graph, we can estimate the velocity of the child at points A and B. Let's just do point A. We don't need to do it twice. So if I want to try to sketch the tangent line at point A, and this is just by hand, we'll get more exact later in this unit, but if I try to sketch or just draw the tangent line at point A, maybe it would look something like that. And what I'm going to do is I'm going to pick a point. Maybe I'll say it looks like my line goes through here, which is 0.9 and 2.1. And then point A, it looks like is the point 0.6 and 1.6. And so if I wanted to find the estimate the velocity of the child, I would find the rate of change or the slope of that tangent line. And the slope of that tangent line would be 2.1 over minus 1.6 over 0.9 minus 0.6, which gives me 0.5, I believe, over 0.3. or 5/3. 5/3 or about, what is that, 1.67, 1, 2, 3, 4, yeah, 1.67. This is meters per second. And so I can estimate that instantaneous velocity by drawing the tangent line and calculating the slope of that tangent line.